going to talk about sequences today, and there's actually two types of sequences that we will work with in this short unit that we're going to do. And all that a sequence is it's a list of numbers in a specific order. Sequence is a list of numbers in a specific order. And each value in the sequence is called a term. And the type of sequence that we're going to look at today and on the next class is an ordered list of numbers in which the difference between each number and the one before it is constant is called an arithmetic sequence. It's A-R-I-T-H-M-E-T-I-C. A-R-I-T-H-M-E-T-I-C. Pronounced arithmetic. It looks like arithmetic,
Yeah,
but it's pronounced arithmetic. So the thing is, difference here. I bolded that word. Let's talk about the difference here. Because we're going to try to recognize whether a sequence is arithmetic here in part 2. But when we're looking to determine if this is arithmetic, what we're looking for is actually what's called a common difference. And if you think back to some earlier vocabulary days, and by the way, common difference is abbreviated as D. Difference means the answer to a subtraction problem. So right above there on number 3 in section 1, it says the difference between each number and the one before it. So what we do when we look here on problem number 2, is this sequence arithmetic? Do 9 minus 4. 9 minus 4 is 5. Or 14 minus 9. 5. 19 minus 14 is 5. 24 minus 19 is 5. Every single time in our list, we take the number and the number right before it, and we subtract. It needs to be the same value. In this case, it's 5. So our common difference is 5, which means that this is arithmetic. Let's try another one. We have 48, we have 45, 42, 39. And some of you are going to type these values in your calculator, but I do want to show my work here. 45 minus 48. 45 minus 48 is negative 3. Or 42 minus 45, which is negative 3. 39 minus 42 is negative 3. And because that value is the same, when we subtract, our common difference is negative 3. And again, this one's arithmetic. If that number, that negative 3, is not the same every single time, then it is not an arithmetic sequence. As we look here at our next section, finding terms in an arithmetic sequence, we want to find the next 3 terms in the arithmetic sequence, 2, 5, 8, 11, 14. Well, the first step when we find the next 3 terms in this is that we need to start by finding the common difference. And again, I won't even do all of them, but 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3. Is 14 minus 11 3? Yes. So our common difference is 3. And once we find our common difference, then we're going to use the difference to fill in the next 3 terms. And what happens is, as we're going to the right in this sequence, we're going to take the number before it and we're going to add. So we're going to add the common difference to it. 14 plus 3 is 17. And as we go to the right, we're going to take the number before it and we're going to add the common difference. 17 plus 3 is 20. And as we go to the right, we're going to add the common difference of 23. We end up to be 23. If we go backwards, 23 minus 20 better give us 3. 20 minus 17 better give us 3. 17 minus 14 better give us 3. As we go to the left, we subtract. As we go to the right, we add. Hopefully, some common sense here for you. So when we look at example number 2 here, find the next 3 terms in this arithmetic sequence. Well, once again, what we have to start with is find the common difference. 10 minus 16 is negative 6. 4 minus 10 is negative 6. Negative 2 minus 4 is negative 6. There's our common difference, and the common difference is abbreviated with the D. And what we want to do is we want to find the next 3 terms. Once again, as we go to the right, we're going to add. This is negative 2 plus negative 6, which gives us negative 8. Negative 8 plus negative 6 gives us negative 14. Next term, negative 14 plus negative 6 is negative 20. If we went to the left, and we didn't have to do that in this particular example here, we would have to subtract. Negative 8 minus a negative 6 better give us negative 2. Negative 14 minus a negative 6 better give us negative 8 when we go towards the left. As we flip over on the back of our notes here, sometimes we're not given all the information. We're not given the sequence, but only information about the sequence. And to help us work with situations like that, we're given a formula that's boxed in there on number 2. Just a little bit more information about arithmetic sequences is they're expressed in this form of a sub 1, comma, a sub 2, comma, a sub 3, comma, dot, 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 a sub n. A sub 1 is our first term. A sub 2 is our second term. And then over here, a sub n is the nth term. That doesn't look very good, but we'll try again. Nth term in the sequence. And if we want to calculate the nth term of the sequence, we use this formula here that's boxed in. A sub n equals a sub 1, which is the first term, plus n minus 1. N is telling us what term are we looking for, and the n minus 1 times d, the common difference. The formulas will be provided to you. You do not need to memorize them. However, we need to know what a sub 1 is, what d is, what does n stand for to be able to use them. But you will be provided the formulas. So problem number 3 here. It says, use the nth term formula to find the general rule for generating a term in the given sequence. Simplify the equation completely. Well, let's list what we know here. A sub 1. A sub 1 means that we're looking for the first term. And the first term is 4. I got a little bit ahead of myself. The common difference, we need to figure out what that is. And again, some of you will just take out your calculator and you'll type it in. There's nothing wrong with that. But it's determined by taking 10 minus 4, which is 6. 16 minus 10, which is 6. 22 minus 16, which is 6. There's our common difference. For n, that's one of my little things that we just don't need, particularly on this problem. All that we want to do in this one is we want to use our formula to come up with a formula to help us find any term in this sequence. And that's why I say general rule. So we know enough information here to do that. A sub n, we don't know what we're looking for, equals a sub 1, again looking at the formula that's in your box on number 2, 4 plus n minus 1 times d, which is 6. To figure out this now, because it says simplify the equation completely, we're going to distribute the 6. So we end up with a sub n equals 4 plus 6n minus 6. A sub n, then when we combine like terms with the 4 minus the 6, is negative 2 plus 6n. That's the general rule for any term in the sequence. So as we move to the next one, start left on your paper so that you've got enough space in there. But it says use the nth term formula to find the general rule for generating the term in the sequence of 1, 5, 9, 13, and so forth. Then find the 11th term. So start left on your paper so that you've got enough space. And let's look at what we know. First and foremost, we know that a sub 1 is 1. But we also want to know what a common difference is. And I'll just put a line here for a minute, because we have to figure it out. Some of you might mentally look at that. Some of you might type it in your calculator. But to determine it, we take 5 minus 1, or 9 minus 5, or 13 minus 9. And every single time that we subtract common difference, we get 4, which is our common difference. The problem here says use the nth term formula. So there's our formula. A sub n equals a sub 1 plus n minus 1 times d. So we're going to fill that in. A sub n equals a sub 1, which is 1, plus n minus 1 times d. And let's simplify that. So we're going to multiply everything in here by 4, everything in the parentheses by 4. So we have a sub n equals 1 plus 4n minus 4. And when we combine like terms, we have a sub n equals negative 3 plus 4n. Well, now that we have that, then the last part here says that we want to find the 11th term. Well, you probably have to write up here to the right of this, so I'm going to write it down again. You don't necessarily, but you probably need that space. We know one more piece of information now. We know that n is 11. It's the 11th term we're looking for. So when we fill this in, our n is 11. So this means a sub 11 means we're looking for the 11th term, and it's going to be determined by taking negative 3 plus 4 times 11. And once again, some of you might just type that in your calculator, some of you can do that in your head, but we get negative 3 plus 44. Our a sub 11 then is going to be 41. let's look at a couple more here to finish here. It says find the 25th term in the sequence of 5, 11, 17, 23, 29. And that's what we've just been doing. So let's label what we know. In this case, we know that a sub 1 is our first value in this sequence, which is 5. We can find our common difference if we do a little bit of subtraction. 11 minus 5 is 6. 17 minus 11 is 6. 23 minus 17 is 6. There's our common difference. And in fact, we know one other piece of information in this problem, and that is n. And n is 25. So it doesn't ask us to find the general rule in this problem. We can go straight to it to figure out our value. What we're looking for is a sub 25. That's the 25th term. And what we know. We know 5, that's our first value. And then we know that n is 25 minus 1. Filling it back into our formula that's in number 2 up above your paper, times the common difference of 6. Type it in your calculator if you need to. But we get 5 plus 24 times 6, which is 5 plus 6 times 4 is 24, 6 times 2 is 12, 14, 149. That is our 25th term. A sub 25. The nice thing about the general rule is, once we know the general rule, we can find any term. This one was specific to the 25th. When we look at problem number 2, a couple things that we need to do on this one. Again, I recommend starting as far left on your paper as possible to fit it in. It says find the first term, a sub 1, of an arithmetic sequence whose common difference is 14, and the fourth term is 79. Then find the next 4 terms in the sequence. So let's list what we know, because sometimes we're given information about the sequence, we're not given the sequence. And first and foremost, what it says is, we don't know what a sub 1 is. That's what we're trying to find this time. We don't know what it is. But we do know the common difference. It's 14. And we also know the fourth term, which is a sub 4, and it's 79. And because we know a sub 4, we know one more piece of information. Do you know what it is? And I tried to color code it, but it's that n equals 4. So when we go back and fill in this formula of a sub n equals a sub 1 plus n minus 1 times d, what we're really filling in is a sub 4 equals a sub 1 plus n minus 1 times d. Because we know a value. We have to work backwards to figure out what a sub 1 is. When we fill these in, 79 is a sub 4. We don't know a sub 1, the first term, that's what we're looking for. But we know n. It's 4 minus 1 times d, which is 14. When we simplify, make sure that you follow the order of operations. So we have 79 equals a sub 1 plus 3 times 14. 4 minus 1 is 3. 79 equals a sub 1 plus 42. And then we can subtract 42 from both sides to figure out what a sub 1 is. And 79 minus 42 is 37. Is a sub 1. Now that we know that, what it says is we need to find the next 4 terms in the sequence. The thing is, when we look at this, 37, we just found it. Second term, third term, fourth term, fifth term. The next 4, then you might have to write it vertically on your paper to fit it in, off to the far right. The thing that we already know is that our 4th term, first term, second term, third term, 4th term is 79. And we can check this as we go along. Remember, as we move to the right, what's happening is we're going to add our common difference, and our common difference is 14. So 37 plus 14 is 51. 51 plus 14 is 65. Does 65 plus 14 give us 79? And then this one's 79 plus 14, which is 93. Ooh. And I will stop there.